Hello students. So today we are going to study about the introduction about the power system analysis. So in this session we will cover what are all we are going to study in this power system analysis. So unit wise we will study what we will cover and what we will study, what knowledge we will get at the end of this power system analysis subject. That everything we will see. So in unit one, the subject name, the unit name is called the power system analysis. So here, when you come into the introduction part, so you can see the general perspective and the overview of the power system and the need for the power system planning and operation studies, right? So overview of power system, that everything you have studied in the transmission and distribution subject. So about from generation to distribution, right? So generation, transmission, and distribution, that everything you have studied in the previous semester itself. So that knowledge uh, you have to remember here, right? And the need for the power system planning and the operational studies, right? If you want to extend the power system, existing power system area, or the size or the capacity, whatever. So the planning is very important, right? And the operational studies, how about that is nothing but about the power flow and the current flow, that everything we will study, right? And the overview of power system, here you can see the generation, transmission, and distribution. So normally the power system comprises of these things, right? So from generation to distribution, right? So next to the components of the power system. So if we take any power system that comprises of, that will have one generator, and then you will have one generator, and you will have one transformer, and then you will have the transmission line to transmit the power, and the distribution lines, and the loads, and the compensating devices, right? So compensating devices like a shunt series and the static V are compensators, right? Okay. So here the generator is used to generate the power. So from the various sources like the wind and tidal and thermal and the nuclear power, right? So from those energies we will generate the power with the help of the generator. So the generated output voltage will be minimum will be lower, like 11 kilovolt. Then uh, if I want to transmit that power to the long distance, so simply I cannot transfer at the low voltage level, right? Because the losses will be greater. So to reduce the losses, I have to step up this voltage level. So for that, here I'm using transformer. So with the help of transformer, I can step up that generator voltage into the higher level. So then I will transmit through the transmission line, and then at last I will have the distribution line for transmitting the power, and at last I will have the load, and the compensating devices like the shunt series and the static VR compensators will be there to monitor the power flow of the power system, and to monitor the current and the voltage level at the various bus bars present in the power systems, right? So these are all the components. So apart from these listed things, you will have the fuses and the circuit breaker, everything you will have in your power system. So, and the functions of the power system analysis, right? So here you can see need to monitor the voltage at various buses. So the first point you can see need to monitor the voltage at various buses. So which is nothing but you will monitor the voltage, whether the voltages are maintained a constant, uh, that everything you will monitor in the power system analysis, right? So voltage at the various buses and the real and the reactive power flow between the buses, right? So real and the reactive power flow, right? So you know the difference between the real power and the reactive power. So real power is nothing but the true power, right? So true power in the sense that the entire work will be converted as some useful work, right? So that is called the true power. So then the reactive power is nothing but what? So reactive power is nothing but the power loss due to the magnetic field, right? So power loss due to the magnetic field, due to the magnetic field. And the functions of the power system analysis, the another point is to design the circuit breaker. So based on the power flow ratings, you will design the circuit breakers and to plan for the future expansion of the power existing system. So already the existing power system will be maybe the size wise it may be small. So if I want to increase the size of the power system, right? Uh, when it will happen? When the demand increases, the power generation need to get increased, right? So when the demand increases, power generating capacity surely it will get to increase, right? So if I want to increase the generating capacity of the power system, the entire power system area must be extended, right? That must be enlarged, right? So for that, the planning for the future expansion of the existing power system is very important to provide the maximum demand or the required demand, right? Okay. And the next point of the power system analysis is analyze the system fault under the different conditions like three-phase fault and the line to ground fault and the line to line fault and the double line to the ground fault. All right. So here the three-phase fault is nothing but the symmetrical fault, right? Which is comes under symmetrical fault. And these line to ground and line to line and double line to ground fault, these three faults are unbalanced. So which are comes under unsymmetrical fault. Unsymmetrical, unsymmetrical fault. Okay. And at last we will study about the study of the small and the large disturbances. So which is nothing but the sudden changes in the load, sudden adding of the load or the sudden removal of the load, right? So when you add or removing the load, the system will go into the instability, right? So in that case, we have to maintain the stability of the power system. For that, the power system stability analysis is very much important in the power system analysis concept subject, right? So when the system go into the unstable mode, automatically it should come back to its the normal stability state, right? If not, you can say the system is not stable, right? So, so we have to maintain the stability under the And here you can see the block diagram, planning and the operation of the power systems. So the entire the power system planning and operation of the power system you can see in this block diagram. So here you can see the planning. Then we have to implement the new plans, and we will monitor the monitoring and comparing the plan with the results. If there is no deviation occurs, so directly it will feedback to the planning, right? If there is any deviation occurs, you will make any you have to give corrective actions, so that you will give to the planning and the implementation of the new plan unit, right? Okay. And dealing with the power system analysis, there are three parts. One is power flow analysis, and the second one is short circuit analysis. So short circuit analysis, in the sense, there you will study about the symmetrical fault and unsymmetrical fault, right? Symmetrical, a balanced fault, and the unbalanced fault. So balanced and unbalanced, and at last you will study about the stability analysis of the power system, right? So under the large disturbances and small disturbances. So small disturbances occur when the uh, small load changes occurs. So that you will call it as small disturbance. So like adding of the small loads and the removal of the small loads.